if this works. Well, I always like people to tell you a bit about themselves, so a bit about me. I started a long time ago in this business. I wrote my first program in 1969 on one of these. Who here's ever used one of these? Okay.
Seen one.
Yes. Slow, noisy, the ultimate status symbol back in the day. You have one of those in your office, you were super important. The only person I ever met who had one was my statistics tutor at King's College. Everyone else had to go down to the computer room with a deck of cards or whatever, and he had one of these. And we stored on this stuff, paper tape. Then I moved to one of these, Televideo 920. The irony is, these cost more than the teletype, which had hundreds of parts. You can say we're so new and so snazzy, and they did 9600 second, but the modem was only 1200, so it didn't really win very much. And I stored my stuff there on 8-inch floppy disks. I've still got one at home. I'm going to put it in a frame on the wall somewhere, I think, because it is a 128K. And then my first type disk was 10 megabyte, and I thought, I'll never fill it. How am I going to type all that much? Yeah, how things change. This one's funny bit. My first bit of open source software was the Lawrence Livermore Basic, which was the first real open source program of significance. I got it from CERN in Switzerland, and it came on one of these, an on-track mag tape. After all thinking, I realized I could convert that at the place where I was working at the time, which was Radi, Fort Halstead, where they had cruise missiles and stuff, because it had a VAX cluster. The VAX cluster had, you opened the door at the back, it had an 8-inch floppy disk drive, which was the bootstrap device. So I went in there one day. You gained admission by pulling on a piece of string, which went through a tiny hole to a bicycle bell on the other side, because it was in a Faraday shielded cage because of worries about RF eavesdropping. And if you remember Tempest program in Ministry of Defence and Foreign Office, when they worried about eavesdropping with VDUs, with directional aerials from outside. So I finally got it converted to an 8-inch floppy, and off I went with Lawrence Livermore Basic. Okay, I started out doing industrial control system stuff, razor blades, crunchy bars. Industrial control systems can be fun. This one is, the crunchy bit in the middle of a crunchy bar is done through an oven on a conveyor belt. You have to pour the stuff out onto the conveyor belt through an extruding mold, and it sits on the conveyor and it goes through the oven. But you have to adjust the mix, but there's a long delay between adjusting the mix and it going through the oven, because if it doesn't rise enough, it's too hard and the punters complain. If it rises too much, it won't fit in the wrapper. So significant stuff. So it was like 3-term process controllers, temperature controllers, proportional integral derivative, where you've got something that has very long latency between you changing the input and the output changing. This is relevant to observability, as you'll see. Hydraulic bending machine. This one was fun. You throw in a scaff pole, and the machine goes like that, and out comes the frame for a wheelbarrow. I used to go to this industrial place up in the West Midlands. I couldn't understand anybody. Sorry if there's anybody in West Midlands. They made wheelbarrows. And before, they used to have a huge old drop machine. The old British industrial machinery was, for some reason, always painted green. And you put in the scaff pole, and it went bonk, and out come the frame. And then another machine next to it, you put in the sheet of steel, went bonk, and out came the bucket. These weren't very accurate. And they had lads with club hammers bashing the frame and the bucket until they fit. When I put in this machine, the union down tools, because the fellows with the club hammers would have no job, because this came out accurate, the bucket fitted every time. So we sat down, cold day, they had one of those ribbon curtains that the forklift trucks used to drive in and out of with snow blowing in and out. And they went up into a porter cabin, and 4 hours later, the union had reached an agreement. Men who had the club hammers would put down their club hammers and become quality checkers. They would check that the bucket fitted the frame, peace was restored, and production was restored. And the production manager was even more thrilled because the wheelbarrows were now really accurate. He could stack more on the truck delivering them and get the truck under the railway bridge at the end of the road. the prosaics of industrial control systems. Razor blades. I did sequencing timing systems. You know, Wilkinson Sword and Schick, which is Wilkinson Sword, and Gillette spent large amounts of money over many years on lawyers suing each other for patents. How many blades, blah, whatever. Of course, the real secret of the razor blades is not in those patents, because patents are public. Who knows what the real secret of razor blade manufacture is? And the thing you'll never see written down anywhere. Anybody? It's the annealing sequences in the furnaces to make the blades, which controls how hard and how sharp the blades are, because they want the blades to not wear out too quickly and not last too long either. So the number of pieces of legal paper we had to sign to be given the sequencing of temperature and breathe, press with the controllers went through about 5 layers of lawyers. It was unbelievable. What else? Military stuff I did. Well, the place where I converted that mag tape, I spent a wet Wednesday playing around on their indoor 20mm cannon range. That's something to do on a wet Wednesday afternoon. Parliaments. This was kind of my dream job. Here's the problem. Here's a pot of money. Go away and do the best you can. It's a complete greenfield site. And I did everything, including putting the wires in, where you're trying to put cables into a building that's 180 years old and was designed only for water and horses. And the walls are thick. I had to get a hole drilled. Fella turned up with a drill this long. He said, sorry, I've only got this one. I know it won't be long enough. And you drill, pull the drill out, and it goes flop. It's 2 walls, rubble filled, and the rubble is wet. Locks all the Wi-Fi beautifully. But when you pull the drill out, you don't have a hole anymore. So you have to have a copper pipe, put the drill in the pipe, and it's like making an underground tunnel. You have to advance the shield as you go. Government department stuff, boring. Big business and a couple of startups. Startups are where you have fun, but they always run out of money is the problem. Okay, why are we here? Observability, shortened to OLI in the same way as you shorten internationalization to I-18N and so on. This originates back here in the days of control systems, hence the connection to what I was talking about in industrial control systems. Describe mathematical control systems because you're inferring how something's doing from the outside, because you can't observe it directly. He wrote stuff like this. Don't worry, I won't be talking about this tonight. So observability is a new hot thing, but why? Well, this stuff's getting more and more complicated. Instead of just computers, operating systems, virtual machines, which are just someone else's tin, you now have containers. Containers are black boxes. You're not supposed to be able to get in there and look at them. Take out your shell, have a minimal operating system, minimize the attack surface. Kubernetes is a black hole. You put stuff in there, you've no idea what's going on. Instrumenting and observing Kubernetes is really hard, especially to do with the networking. Service meshes, a new black art. Make one line configuration error in this much YAML and you've blown your entire network security. Fortunately, AI is coming to help, at least to do checking of your declarative code, because in some ways declarative code is harder to debug than imperative code because the verbs are non-obvious. You can't should be able to, so you only know what these containers and Kubernetes and black boxes are doing, either by what they tell you themselves or the questions you ask them. And that's what modern observability is founded on. Now, the 3 pillars, the vendors of monitoring software have been touting these 3 pillars as the core of observability. But they've been doing this for years. They just put a new observability go faster stripes on it and called it new, wonderful, fantastic, buy now while stocks last. So it's not the whole story. Metrics are problematic. Metrics are aggregates. They're not only aggregates of a value over time, the very value you're aggregating is an aggregate of other values. What's CPU load? It's a number. Really, all you're looking at is how hard the thing is working. It doesn't tell you what's causing the load. You've got to dig in. And this is true. Just because something's increased, it doesn't necessarily mean it's bad. And just because something decreased doesn't necessarily mean that it's good, because it's the percentages that matter. Now, metrics and alerts are reactive. You can only react to them after they've happened. Okay, you can do some trending, you know, it's going up. This is back to the 3-term process controller. You know, the temperature is rising, better turn it off before it gets there, otherwise it'll overshoot. Same principle applies to metrics. Metrics are often put into time series databases which do naughty things with the metrics, which mean you can really only get back out the stream you put in. You can't do proper queries across the stream because it's delta, it's compressed, delta of deltas, and all kinds of things, so they can pretend to be more efficient. Here's the other problem. You put an alert onto a metric. Why? Why is that metric significant? And what threshold do you choose as being significant? They're kind of type values. They're a finger in the air, because you know, you may know that if the CPU load goes above 40, it's likely to shut down for overheat, but that's about all. You're not getting much better than that. So monitoring is for known knowns. You must know why this metric is important and why a threshold you've chosen is important. Observability is for the tough stuff, the unknown unknowns, the so-called fourth quadrant stuff. Who's a fan of Nassim Taleb, who did the stuff about fourth quadrant, black swan hits? He was talking about the financial world. And one of the things he said was, the next big hit you have will not resemble the last big hit, because you've already mitigated that. So it'll be a new big hit you haven't thought of. So we need not just what happened, but we need something to help us go why, because only by understanding why can you fix it. Okay, really important metrics. Not the stuff you fish out Prometheus, although Prometheus is a great program. Version 3 has just been released. If you're interested in Prometheus, go and check it out because it's really good. DORA. There's 2 DORAs, very confusingly. There's the one of the DORA DevOps metrics, and the more recent one, Digital Operational Resilience Act. And everyone gets confused about this. But these are really important metrics which are out of your SDLC, your CI/CD, your software development tool chain. How long, the classic question is, how long will it take you to make, build, compile, and deploy a one-line change of code? That's a metric you should know in your organization, because some of that is an organizational problem and not a technical problem. Deployment frequency. How often are you deploying? Because the faster that happens, it's usually a sign you're going better and doing faster. Mean time to recovery, obviously. How quickly can you fix something? That depends on these 2. And then change failure rate. How often does the change you make fail? The question every programmer should ask themselves with writing code is, if this doesn't work, what will break? Because only if you do that will you know it's gone wrong, because you've already worked out what might go wrong. Then the DORA, the Operational Resilience Act, that's all about, systems reliability, disaster planning, disaster recovery, all that kind of stuff. All the stuff they didn't do with the electricity supply at Heathrow. So observability is every bit as important in your CI/CD pipeline as it is for the apps. It's not just about monitoring the running applications in production. You need it everywhere. Logs. This is where we all started. You know, when I was writing my stuff on paper tape, occasionally the mainframe would spit out a bit of paper with something on it about what went wrong, a kind of log. Nowadays, we just stick them all in Elasticsearch or OpenSearch. We don't like Elasticsearch's license changes. And then they stick metrics in Elasticsearch, which of course is a really, really bad idea because of the problem of cardinality. Text indexing is not suited to high cardinality data. And then we look it up at Kibana and we look at what's in by result. Not really. Logs are usually unstructured. Better to structure them. It's not just strawberry jam, as my old English teacher used to call stuff written without punctuation. There's no context. Where was it called from? And how are you supposed to correlate it? Okay, what are you logging? Platform logs. Okay, that's what's coming off the system that is hosting your application, whether you're working directly with the operating system or with a container and a container runtime or a container and Kubernetes. Deployment logs from artifact repository to running systems. These are important for audit. Something goes wrong, you want to know from what date. So I got to go back and look for things that have gone wrong because of a bug in that deployment. Application logs. Your applications must emit signals. You can't rely on the stuff from the underlying operating system, container runtime, whatever, orchestrator, whatever. OpenTelemetry project, which is excellent, by the way, was created specifically for doing this sort of stuff. Not only does it provide you with ways of bolting OpenTelemetry into your code by means of software development kits, it also specifies the wire protocol that the records are sent over and the structure. This is the definitive reference for OpenTelemetry. If you're interested, go look here. Now, traces. Traces work on you add a timestamp to the TCP header, the header of your TCP packets. Why? Well, you put a timestamp on when you send it, and then you get it, you compare the timestamp to the time now, and you figure out how long it's taken. Now, of course, in a good fast network system, that should be microseconds only. But we all run microservices and distributed systems these days. And what you're also looking for is not just transmission from A to B, but between your microservices, because what you're looking for is something that's gone slow, bottlenecks. So you'll have a timestamp for when it goes into something, when it comes out the other end, and that way you can look for trending, something getting slower and slower. Why? Go look before it gets too bad. Jaeger and Zipkin are a couple of examples of these. This is another brilliant, fairly recent thing. eBPF, extended Berkeley packet filters. They're a bit like magic. You bolt them in and they can instrument almost everything that's going on without requiring root privileges. They work, you can plug in an eBPF program that will listen to all your in and out network traffic and give you logs and metrics and stuff out of it. eBPF it's far too complicated to go into here and now. We'll make a great presentation on its own, but a little bit off topic for DevSecOps before Roy gets excited. Span is what you do with those traces. Because what you want is, it's going through, you make a request to a system now, it'll receive it, it'll pass it on to something else, you do a database lookup, it'll create a response and send it back. Each of those steps has a time and a latency, both in the doing of it and in the transmission between them. So spans allow you to do that all the way through, because what you do is you add a unique identifier to the request, a UUID, for example, to the inbound request, and you send that along all the stages. It does nothing except provide an identifier, and it's usually referred to as baggage because it's non-functional. It's just an identifier. Rich content. This is how we're getting to where observability is going. The richness of the content. Anything relevant, just capture as much as you can. Storage is cheap. Your time isn't. It will help you find things out later. Think multidisciplinary information capture. This is a good way of looking at it, because you're looking at not only the stuff from the system, but the stuff from the application, and also stuff from the other end. A web request goes wrong, and if you have all this information, you find out it was only from someone using Microsoft Explorer version blah fooey, if they do it in the time zone in Hong Kong. You're going, what? But you drill into there, you'll find something that is a common factor, but you've got enough information to achieve that common factor to indicate the problem. Structured records, JSON is almost universal for this. Distributed traces. Sorry, I kind of went on to the next slide without doing it. The flow of the request through the system. So we're getting closer to observability here. Now, properly instrumented applications. Applications must emit their own signals. Only the application knows what's a meaningful event in the processing of a request, data, whatever. This is the one Hafner Amendment. An application is poorly instrumented if you have to add something to instrument it. It should be written with that instrumentation in it. It should not just leave it to the platform layer, because the platform doesn't know what the application does. It only knows something went in and something came out, maybe, or perhaps it didn't come out. That's a fault, but not why. You write it, you run it. That's what you tell all the developers when you're trying to herd cats in your DevOps team. But it needs to be, you write it, you instrument it, so you can debug it, because you're the best person to debug it, because you wrote the bloody thing. Now, that's about cardinality and dimensionality. Cardinality is about uniqueness. So a UUID is mathematically designed to be as unique as possible. A social security number is unique, a date of birth, not unique, gender, hopeless, right? So you need that because you want to be able to go that one or that system or something. Dimensionality is different. Dimensionality is the number of keys. So in terms of a database, you could think number of columns. And each row is a value for those keys. Because this is what you want for correlation. Because you can correlate across between the dimensions. Because that can provide very useful information about things. So basic rules, catch everything you can because you don't know what you might need later. And it could be something completely unsuspected. Storage sheet, yes. Yeah, the more complex you make things, the harder they are to instrument and debug. It shouldn't be a surprise, yet there it is. Monitoring is not the same as observability, as I hope I've just demonstrated. And deployment observability is every bit as important as systems observability. Now, fantasy design, you can play fantasy football, I'm playing fantasy design here. Ship those structured records to Kafka. If you don't use or know about Kafka, it's an absolutely brilliant tool. It was created by LinkedIn to swallow the vast volumes of logs that they generate. And one of the biggest current users of Kafka, which is event streaming, think a database table that moves. So it's constantly on the move. You add records, you can delete records, you can't change the records. This is to keep it simple. One of the biggest users of this kind of streaming data is Uber, who have hundreds of Kafka servers. Nearly all their microservices are actually based around Kafka streaming data. Very interesting stuff. So if you think Kafka consists of a series of topic streams, which you can think of as a database table. You go into that, you push into that, and it goes down. Now, it's often somewhat misdescribed as a messaging system. It's not the same as a message queuing system like AMQP, RabbitMQ, and some others. You put something into a messaging system, it goes into an opaque pipe, and it's push delivered to a number of targets. And when it's been delivered to all those targets, the message is deleted. In Kafka, it's not like that. The pipe is transparent. You can run SQL queries across that moving pipe of data with extra parameters in your SQL select, which can say last 20 minutes or something like that. And the targets are not passive. They pull the data from the topic queues with their own cursor pointer. So you can add new listeners, as they're called in Kafka, almost without limit because they place almost zero load on the actual data streaming. So the other key is, after all the listeners have received the message, it's not deleted. It remains in the queue and you delete it only by aging it out or a maximum data size. This is great for audit. And it's also great for doing debugging because you can do things like, if you're passing your data in your microservices setup through this, and you get in a data record, you pass it to an API or something, and it breaks, shit. Okay, we fixed it. Now you can do an action replay. You just move the cursor back to the point before that record that broke the system and try running it in again. And you've done your testing of your fix to cope with the data that broke it. There's a whole ecosystem of stuff almost entirely from the Apache organization. Kafka itself is an Apache project and has been for a long time. Flink is the other one that is now becoming really, really strongly associated with Kafka. We're doing more advanced things. Not everything is done in Spark. What's the one written in Python? The data processing one written in Python. It'll come from and so on. This is a handy toy. It was so handy, Datadog decided to buy it. It's a nifty little binary, I think, written in Rust that has lots and lots of input and output connectors, one of which is Kafka. So you can read the Kafka topic streams and do things. Now, because what is it you want to do? You take that input record, it's going to have these various data points in it. What you're looking for is, where does that data point match with something else? Or is that data point a key I can use to look up static data in another database, bring it in? So you enrich the record, you write it to a different topic stream. Enriched records, that stream. Rinse and repeat. Your goal is to have a topic stream of actionable intel. Here's a problem or issue, and here's some context to help you solve it. That's the real key. I worked at the Met for a while, Met Police, doing some strategic consulting there, and I tried to get the Met interested in becoming an event-driven organization, not for the IT, but for their actual operational stuff. If you think about it, the Fuzz is the ultimate event-driven organization. Shit happens, you've got to go and deal with it. So you might have an incident report. What are you going to do? You're going to go and check the ANPR, the automated number plate recognition stuff in that area. You'll match those number plates with some names. You'll look names up with modus operandi, known associates, that kind of thing. You're enriching the record down to the point we can get actionable intel before the boots on the ground get there. That's the goal. And of course, that's every bit as applicable in a military context, in tactical theatre operations. And it's not just for humans. Auto remediation systems will benefit from having actionable intel, or they might make some really bad decisions. And they do sometimes. Okay. It's not just anymore, because you're gathering so much data and you've got such flexible processing capability with it, you can now serve other business interests. DevOps itself. I worked at a fintech company a couple of years back. And their observability was rubbish. Put in the Kafka-based system, I got all this extra data. I went round to the head of the business unit. I went, look, all this extra data, we could do something with that. Do you know how we do it at the moment? I said, yes, I do know. You ask her over there to make you a spreadsheet once a month, dumped out of the database. Isn't this going to be better? Audit. This is a super important one, and where Kafka and similar systems can absolutely save your bacon, because you can keep all the stuff necessary for your audit, compliance, even GDPR stuff. This can help you when the lawyers come around and bang on the door. You've got the answers to their questions. You hope they're the right answers. Security, of course, incident response is just as important in security as it is in stuff going wrong. And more. For me, it's the obvious way ahead to do this. Now, wide. Why wide? This is really about make this record one huge JSON instance with everything you can grab your hands on that's available at the time, because you don't know what you're going to need later. Stuff that out as a single write, because it's the starting and the finishing of a write that's expensive, not the write itself. Now, these are three excellent references about wide events and why you want them. This last one is charity measures. Who knows charity measures? Yes, Charity Majors is founder of Honeycomb, the observability company. Charity Majors is about this high with purple hair and tattoos and a squeaky potty mouth. She's had to clean up her swearing. Now they've become a public company. But if you read some of the older stuff on her blog, which is Charity WTF, there's some really hilarious stuff in there, but she's super smart and absolutely knows what she's talking about. These two, this is the definitive reference about wide events, and Charity referenced this one, which is how I found it. Read those three. They're not that long. They're about 8-10 pages, but they explain why you should be having wide events and not narrow focus stuff. Okay, so where does that fit in with DevSecOps? Because I have to make it relevant for Troy. CI/CD toolchain again. The point from code commit to running deployment. Auditable builds. Who did this build? Who did the code commit? When? Was there a why? Did he supposed to put a why in the comment for the Git commit? Did he? No. Supply chain integrity. You know about sheep dips? You bring in an artifact, and before you use it, you leave it in the sheep. Sorry, you leave it in the sheep dip a while, and you run CVE checking or any other checks that you want before you then pass that into an internal repository from which it can be deployed or included. And includes are the real problem. Dependency import tracking. Maven, of course, I'm looking at you here because you're so notoriously bad at this. Who remembers the log4j incident? And people are going, but I don't have log4j. It was a transitive dependency. And people had to run active pen testing on their own internal networks to find out where log4j was running, which shouldn't have to happen. If a person's compromised, if Fred's sitting over there in the corner and never talks to anybody, he turns out to be a bad actor, I want to know where his code is running on my state. Every commit, every build. If a component that you import is compromised, or a source, repository pollution, that's another big issue these days. If any of these are found to be compromised, I want to know where that stuff's running on my state and prioritize going to remediate it. And they may not be running, they may be stored in an artifact repository, waiting to be deployed on an event or load shedding or something. You've got to look everywhere. Okay, conclusions. Ollie must replace monitoring. Logs, metrics, traces, not enough. They're there to impress somebody, but they're not actually that much use. The 3 pillars are not enough and never were. We know this now. Apps. If you run DevOps chains and you're dealing with developers, you have to encourage, beg, or threaten them to instrument their applications, or you're flying blind. Capture what you can, high dimensionality, high cardinality. Don't just rely on text search, have more sophisticated stuff. Work with your observability data to make it more useful. Now, AI can start to be really useful here, because for me, investigative AI is far more interesting than generative AI. I'm much more interested in what AI can do with all this data than I am about generating pictures of celebrities with no knickers. Okay, my reading recommendations. This one is the book you buy for your managers. You send them away to read it, and if they come back and go, I don't understand, you tell them to go back and read it again until they do. This is all about accelerating your organization by using the automation principles of DevOps and so on to make you high performing, high productive, because all of these things actually make you be a better organization with better running code. Speaking of which, this book has turned out to be a huge hit. It sold over 100,000 copies, which for a tech book is a startling number. I know Matt Skelton. He's a mate of mine. He's a lovely guy. I highly recommend this book. This is how you do that. And what it does, team topologies, it's a different way of structuring your teams into 4 groups of activity. There's a workbook that goes with this that explains, if your project manager explains how you do this. The book is excellent. This one, of course, is the definitive work on site reliability engineering. The book's a bit old now, but the wisdom in there from Google from many, many, many man years of experience in Google is without. This is the new one. It's Charity Majors. Look, and Liz Fong-Jones, who is her mate over at Honeycomb. I don't know who George Miranda is. But this one is how you an in-depth look at doing observability engineering, wide records, all the stuff Honeycomb made into a business, and they sell this as a business. Well, that's it. Questions? Thank you.
Just see if there's anything online. Well, while I'm checking online, is anyone in the room?
Okay.
I see one major thing missing, but that's with my training first as a physicist, and that is you need to ensure that the way you're taking the observation should not change the state of what you're observing.
Heisenberg uncertainty. Oh. Yes, but mostly you're querying things that have either been written or are there to be queried or are emitted. So you're not changing the state.
But I saw this problem when I joined BT in 81, and BT designed System X as a first digital switch. And GC and Plessy were so happy they were going to produce this switch. Then so this said, yes, a switch. And then somebody said, we want to still produce this red book of statistics. So when GC and Plessy, right, all these measurements, all these statistics must be produced, they discovered a quarter of the switch's processing power went into producing the red book statistics. And when you
press somebody,
yes, but when you looked within BT, nobody was reading most of those statistics. And years later, I raised the question in BT that there was something wrong with my local System X switch. And with all those statistics, they should be able to determine, because it was time of day, what was happening. I said, oh, very sorry, but in the first 5 years, the experts were around who knew how to read that data. Now they've all gone. There's no successors. We don't know how to use the data.
My first boss always told me I would never employ someone who worked for BT.
Good.
Plessy, I worked with Plessy Watchman radars for a bit. A fun story in there, which is too long for them. And Plessy, they're the ones that made that torpedo that used to come around back at you.
We could tell you, then we'd have to shoot you.
Mark V. Yes. Okay. Yes, you're right. Most of the modern stuff, there is negligible loading by either you're tailing a file or you're swallowing a TCP stream or you're querying a database, or in the case of Kafka, you're querying the stream that is intended to be queried across the whole stream. Because you can use Kafka as a buffer as well. So if you've got something that doesn't swallow things that fast, you can use Kafka as an elastic buffer. And you can also, there's something very cunning you can do with that with Kubernetes. KEDA, Kubernetes event-driven auto-scaling. So you can look back the queue of incoming stuff and launch and scale up your Kubernetes cluster, which can be done in a few seconds, not like launching new VMs with AWS's automatic thing, which takes you several minutes. So you can respond dynamically to inbound traffic load by scaling up your Kubernetes cluster. So the modern systems, you're right to ask the question, but the modern systems mostly decide that doesn't.
You've got more processing power. Yes.
Exactly. It makes all the problems of bad coding go away. Yes. All run faster in the end. Yes, yes. Sorry, who else had a question?
For Kafka, on-premises networks, you recommend inside Kubernetes or off Kubernetes, and if inside Kubernetes, then the same other tools are specifically in one's cluster.
Well, Kafka is not designed to instrument Kubernetes. You can run it in Kubernetes, but Kubernetes can get it to emit the logs you want. Fortunately, the Kubernetes ecosystem is now achieving a bit of maturity, and there are a lot of tools around to help you with Kubernetes, but it is a tricky beast to manage because it's so opaque. You have no idea what's going on in there unless you have these instrumentation tools. And you can rapidly get yourself into a situation where nobody in your team actually understands how the whole cluster is running, probably because it's got shared tenancy as well, which is another big complexity. And you have to be very careful in turning things off or tweaking things because you might break someone else's work, service meshes in particular. Yeah, but Kafka, you can run Kafka in Kubernetes. Probably I wouldn't do that. I would use a managed service. Amazon offer an equivalent, it's called Kinesis, I think, but you can buy the Confluent. Confluent was founded by the guys who wrote Kafka. They went off and made a company and made some money. So you can get it from the Amazon marketplace as Confluent.
On-premises network.
And have a managed, in particular, of course, what they do well, that is not so easy for yourself, is dealing with updates. Because if you want to do the updates without loss of service, it's non-trivial. Yes.
I have two questions. Sorry.
That's all right. No?
The first one, not exactly a question, rather a request. Just can we have a recap on what's the difference between monitoring and observability, just to, for my better understanding, monitoring and observability. And the second is a question because you mentioned that it's so cheap and easy to store data too, but in an organization and throughout the years, of course, we need to create kind of data disposal procedure.
Of course.
So what's your opinion or what's your aspect on that measurement, or how the policy, which data comes first, be disposed and so forth?
I'll answer the second question first, which is capture everything you can think of and store it in cheap stuff like S3. Have a retention and policy and deletion policy. Use tools to extract what you know you're going to need in the future. In other words, it's not short-term horizon data of the problem today, the problem last week, or the problem 3 months ago. You have to decide a retention period based on the dynamics of your organization and your applications. But you should extract the stuff you know you're going to keep long-term audit compliance stuff. Some countries want it, I think, 7 years. You've got to write that stuff out and have a retention policy for 7 years. You obviously can't keep everything all the time. You have to decide what needs to be kept. But if you use tools like Vector and other ways, or just your own custom stuff, Airflow is the Apache one that runs Python and runs with Spark, and you can do jobs in Airflow that you can pull stuff out of Kafka. If you're interested in performance data, you can take stuff out of Kafka, and I've done this, and you put it into Apache Doris, which is an OLAP type database. So it's columnar oriented, very good for doing performance type and those kind of queries. And you can use another brilliant Apache tool called Superset, which is a visualizer. Think Tableau, but without the price tag. And in some ways it's better than Tableau. And you can turn that loose on Doris and not Doris, Druid. Wrong one. There's two databases, very similar names, but very different reasons. Druid. You can turn Superset loose on that and give you some wonderful visualizations, including geo stuff. Difference between observability and monitoring really is the depth and extent. Monitoring is just, you got this stuff and you'll set some alerts and you'll put it in a search machine and you'll let Kibana loose on it. It's simple, primitive, it's what we've done for years, but we need better now because of the increase in complexity, the rise of microservices, the black boxes of containers and the black hole of Kubernetes. It's not, you can't log into the mainframe anymore and go, what's using up all the horsepower? You can't do that. It's very hard to work out which container is using all the resources in a runtime. You've got to have the specialized instrumentation for doing that. Containers crashing and being automatically restarted. If you don't keep an eye on that, it's like having a, who remembers a spanning tree protocol in Ethernet? Yes. So I had spanning tree protocol running when I was at the House of Commons. I computerized Hansard and parliamentary questions, and I had 2 fibers between buildings with spanning tree Ethernet level. Paddy with his JCB came around and dug up one of the fibers. Nobody noticed because the spanning tree had done the switch over, but there was no instrumentation on it because the Ethernet switch didn't have the instrumentation necessary to tell you that the failover had happened. It had the facility, but not the way of saying, hi. That's the difference between now and then and how much more deeply we need to understand how our shit works in order to know what we need to know about it, because the complexity is just getting worse all the time. I hope that answers your question. It was a bit lengthy, sorry, but that answers the question.
I've heard the opposite saga about redundancy, that two sites talking to each other, they didn't realize they were relying on both cables or both routes, and when one of them went, suddenly all hell was let loose. And
of course, the other way you can have is Ethernet bonding, where you run several Ethernet connections in parallel for capacity. Not resilience, but for capacity. You can have one of those fail, it doesn't matter, except things may get a bit slower. Ethernet is brilliant, but it's very poorly instrumented. You rely on everything about
limitations.
If there's some, maybe if there's somebody else in the room, there are some things online, so I'm going to give the people online a chance.
Anyone in the room?
Yeah, we can come back. Maybe they'll think of something. So
wait for a glass of wine.
yeah. So we've had the same question that Moses asked, which was what's the difference between monitoring and observability? So obviously,
I obviously didn't make that clear enough.
No, it's good. It's good, and it might be somebody joined late. And then a couple of questions here. Touching on AI, one very specifically about AI. So it says, are there any AI projects, maybe open source, currently available, which apply to observability?
I'm sure there are. I have been avoiding the Wild West of the AI market at the moment, which has turned into the kind of crypto coin cowboy type area, including some of the same cowboys, by the way. So I'm going to pick up AI later this year. As I said earlier, I'm interested in AI for analyzing stuff, making sense of stuff. And helping with the auto remediation. Because the simple IFTTT stuff, if this, then that type of auto remediation, it works, it's simple, but it's primitive and it doesn't cope with all the cases because it doesn't have any context. You can't just do that on an if statement. AI will help with that a lot, I think. And I think AI help you run your Kubernetes clusters, and then it will suggest 50 different ways in which you can make the cluster more efficient and more complicated and even harder to debug. No doubt.
Okay, so another AI question, which might irritate you, but it's a follow-on from the one we've just had, which is, are you aware of any open data resources that could be used if you wanted to do your own AI training, which I personally think is a very bold thing to try and do.
But there's a big snag here, which is the people who've been very kindly making open data, it's called OSINT, open source intelligence. The people who've been very kindly making this stuff available, they're getting a bit cross about companies hoovering it up to train their AI models with. And they're going, well, we won't let you do that anymore. We're going to make it, restricted. Now, the problem with that is the few open sources that remain, you now have less resilience in terms of data pollution. A big worry is actors with enough resources and motivation, think state level actors, can go after these data sources and subtly pollute them so that your AI query engines give you the wrong answer or an answer that benefits them. This is why I'm very, very cross with all the ill-informed banter about restricting AI, because it can generate pictures of celebrities with no knickers. What is the number one reason why we should not restrict AI in this country? Suggestions? Because our adversaries of all kinds will not. It's a weapon, and you must remember that it is a weapon and is going to be used by such as our adversaries. And our number one reason for having the best AI possible is to tell when they're using it. Nowadays, it's mostly obvious because it's early, primitive, or by context, because that celebrity probably didn't go around wearing no knickers. So obviously it's a fake. In a few months' time, it'll be harder. In a few years' time, it'll be impossible to detect without AI. That's what we have. And we have to look for that subtle pollution of the source information spaces, because our engine is now giving a different answer to the same question as it was 3 months ago. This is a tough area and requires minds far better than mine to deal with, but it needs to be recognized as a significant threat.
Is anyone else in the room? Whilst I've got a question from something I thought about. Yes. Yeah.
If observability is best practice, and I'm a large organisation, I'm going to say, right, guys, with hundreds of apps, we're going to be doing observability.
Yes.
through the measures, you mentioned the DORA measures. I mean, presumably some really good case studies about how that's worked and there's an overhead to doing it, but there's a net
Of course, there's
gain.
an overhead, but there's also a bigger overhead to not doing it in terms of the downtime when shit hits the fan. The starting point is making your developers instrument their code. Most systems nowadays have some sort of instrumentation built in, even though you might have to turn it on and configure it. But you can't instrument the apps unless the developers put it in the code. That's it. Make them have the SDKs. Once you have the SDK, it's a one-liner in the app to emit a signal to an open telemetry collector.
So just a final question I had was around, I think you touched on it, Andrew, when you talked about Log4j.
Yes.
Were you suggesting that using some techniques of observability, you could be maybe keeping an eye on when new vulnerabilities are coming out and then correlating those with applications that you've got, so therefore you could perhaps say, am I vulnerable to this new thing?
Ideally, your build process should check for CVEs on all the things you import. But that's not enough because the CVE may be only discovered later after you've installed it into your code and it's sitting in your artifact repositories. You have to check all the time.
Exactly. It was that which I was referring to.
Exactly. All the time. That should be a several times a day activity. Run through everything in your artifact repository and check it against the CVE lists.
So one of your sources needs to be those new CVEs that are getting created and
Yes. CISA put out a very good one. There are various others that put out these CVEs. You've just got to correlate all of them because they don't synchronize, or they only synchronize later.
So it's an interesting angle on observability. It's actually observing other people's things that are going on.
It's observing your activity because you're bringing that in. So it's your activity that needs to be observed.
Oh, I'm saying you need to join the two together.
Just a comment, not a question. Do I remember right? Log4j was discovered after many years, like 5, 6, 7 years, circulating around on the internet. Everybody used that process. Once it turned out and being logged as a CVE, then after 7 years or so.
Yes. Because
so that's pointing out how hard is this, because even you have a good observability system, but if the whole industry hasn't discovered that, it's just running,
like so many vulnerabilities, it will not have been discovered by the people who wrote the code. It would have been discovered by the people exploiting it who've gone around looking for vulnerabilities. Remember the SolarWinds one? You know the story of how the SolarWinds vulnerability was inserted. It's very interesting. Do you know the expression living off the land? So the bad guys get into your network and lurk and listen and watch. The SolarWinds one was the mantra, don't trust anything, but had to be expanded to don't trust anything, even the stuff you built yourself. By watching, what they found was in the development pipeline for the SolarWinds, at one part of the chain, it wrote out a file with some stuff in it, which was then used further down the chain. So they perturbed that file between writing it and reading it, and that screwed the whole code because it trusted the file it made earlier. Well, it's ours, it must be all right. No, it's not. You must always assume the bad guys are in your network already, which is why you need to have zero trust networking, not hard shell, soft center approach, firewalls only, and VPNs are now just an accident waiting to happen. Don't use them. Zero trust networking is the way ahead. That's another fascinating subject for a topic, but it's a little bit off topic for DevSecOps because there's no dev in there, but there's certainly sec and all. But it's getting tough out there. That's what I'd conclude. And getting tougher all the time because the number of threat actors is multiplying, and AI tools are only going to make it easier to become a threat actor. Bear that in mind as well.
Brilliant. Okay, I think we've had a really good session.
They've had enough.
Absolutely. Thank you very much for the questions, both online and in the room. And finally, just thank you again to Andrew.